All right, so problem solving with quadratics. I have quite a variety of examples just kind of get you guys used to the process with this stuff. So we're going to kind of try a few different kinds of problems. They're mostly word problems, so we'll talk a little bit about that. Get your stat box. And then back to make sure you get that. Section 1F, problem solving with quadratics. I saw Miss Collier. Not Collier, but Chavez. Is it R? Tell me about that. All right. So here are kind of like the steps to problem solving with quadratics. The very first thing is translate into algebra. You're going to get a sentence or question or whatever, a little paragraph, and you have to take what it says and write it into algebra, into an equation. And like I said, we're going to look at a few different types of these so we can kind of cover the different things that you will see. After you translate it, then you solve it. And so I know we've talked about this quite a bit, but that solving piece is a lot up to you. Like, you can choose to factor it if it's factorable, and if you like factoring. You can choose to complete the square if you feel like that's what you want to do. You can always use quadratic formula, so it's good to know. You gotta know that one. And so I'm not, like, when you get a problem like this, I'm not going to be looking for a certain way of solving. I'm just going to be looking for, like, did you solve it? Did you get the answers? After you do get answers, you do have to take a look to see, are your answers acceptable? So if we have a question that is dealing with some kind of length, can you have a negative length? Nope. So you might not be able to use both answers that you might find. Also, if you have a question that says how many people, you can't have half a person, so you can't use like a decimal answer when you're talking about like how many people. Your answer must be an integer. And then it's always nice to kind of complete your answer by putting it in a sentence. Alright. So our first example goes like this. Two integers differ by 19, and the sum of their squares is 185. Find the integers. So this is going back probably to Algebra 1 when you went over words like differ or difference and sum and product and quotient and all those like words and how we know what those words mean, and now we have to translate them into algebra. Oh my goodness. My green thing is on, right? Alright, I don't know why that did that. Okay, so what does differ mean? Oh, sorry. What does differ mean? Like, what operation would differ be? What do you got? Subtraction. So let's say that my first number, one of my numbers is x, then the other number would be x minus 19 because of that word different. So I've got x and x minus 19. The difference between those two numbers is 19. After that, I can set up an equation using the rest of the information. I know that sum is an addition, but it's the sum of their squares, so I'll have to square them and add them. So it would look like this: x squared plus x minus 19 squared equals 185. So that's basically step one, is we were able to take that situation and write it in algebra. We translated it into algebra. So we've got x squared plus x minus 19 squared equals 185. Now we have to solve it. So we're going to want to sort of expand that, combine all of our like terms, get everything over to one side, and then decide how we want to solve it. So I've got that x squared. When I FOIL this, you might take one step. I'm going to go ahead and use the shortcut. So I have x squared minus 38x plus 361. So again, you might take a little bit more steps when you FOIL that. That's fine. Then when I combine my like terms, I've got 2x squared minus 38x. And then I've got to minus that 185 so that it equals 0. So I have plus 176 then equals 0. Now it's your choice. If you want to FOIL, if you want to factor it, if you want to complete the square, or if you want to use quadratic formula. Any thoughts out there? Yeah, thoughts? You want to complete the square? We do have to divide by 2 then. Let's complete the square on the next one. Okay. What do we take out that 2? If I take out that 2, so I can divide it out by 2, I've got 8x squared minus 19x plus 88. So now, looking at this, it's not so bad. What are the factors of 88 that will combine to give me 19? Absolutely, 11 and 8. So I've got x minus 11 and x minus 8. Now if I set 2 equals to 0, that's not going to do anything for me, so I end up with x equals 11 or x equals 8. Now we do have to do a little bit more here. This is not my final answer, but we did do the solving piece. Now we have to kind of get that final answers and like look to see if our answers are appropriate. Are there any questions before we kind of finish it off? So going back up to here, I had x and x minus 18. Well, if x is 11, if I do 11 minus 19, I get negative 8. So then I have 11 and negative 8 is like one set of answers. Those two numbers differ by 19, and their sum is 185. But then I also had x equals 8. So if x equals 8 and I do 8 minus 19, I get negative 11. So I could have positive 8 and negative 11 as my two integers. So two different sets of potential answers there as far as what our answers could be. 11 and negative 8 or 8 and negative 11. Any questions before we tackle another one? Yeah? I just went back to this. If I had x and the other answer was x minus 19. All right. So this next one says the product of two consecutive even numbers is 224. Find the numbers. So, do we remember what the word consecutive means? I think you talk about it kind of a lot in geometry or often in geometry. I know. It's interesting how much geometry comes back this year. Like not so much last year, but like in IB. So consecutive is like next to or in a row. So consecutive even numbers would be like if we're counting by twos. 2, 4, 6, 8, 10. So any of those two even numbers that come right after each other. So if, let's say, my first number is x, my next number that would come, the next even number after that, would be x plus 2. So the next one after that would be x plus 2. Does that make sense? So like if the even number happens to be 38, what's the next even number? 40. 38 plus 2. So now it says the product, and we know product is when we multiply. So I've got x times x plus 2 equals 224. So when I distribute that x, I've got x squared plus 2x equals 224. Now we had a special request to complete the square, which I'm kind of excited about. So we're going to solve this using complete the square, but you don't have to. If you don't want to, bring that 224 over and factor it or use quadratic formula. Does that make sense? But since we are completing the square, I just left it like this because I can put my blanks on both sides. And c, remember, is b divided by 2 squared. So b is 2. 2 divided by 2 is 1. And 1 squared is just 1. And on the right side, when I add that up, I've got 225. On the left side, I'll have my binomial squared, which is going to be x plus 1. Remember, it's this number right here that goes in your parentheses. This one works perfect. This is a perfect complete the square example because I think it's the least amount of work, actually. But that's just my opinion, probably. So now when we square root both sides, we end up with x plus 1 equals plus and minus 15. So the square root of 225 is 15. So x equals negative 1 plus or minus 15. So if I have negative 1 plus 15, that's going to give me 14. But if I have negative 1 minus 15, that's going to give me negative 16. So my two options for x are either 14 or negative 16. I am going to have to go back and plug it in to find like the two pairs of numbers that go together. Did anyone try to solve it with a different method they felt more comfortable with? What'd you guys do? Okay, so it works out. Now, plugging that back in, let's say that x is 14, then 14 plus 2 equals 16, so I could have 14 and 16. Those two numbers are consecutive even numbers, and the product's 224. But if x is negative 16, then I would have negative 14, So negative 16 and negative 14 are also two consecutive even numbers whose product is 224. So both of those options work out. We've got another geometry-ish example coming up.
Yeah. So the steps it said to like make sure you write your answer in ascending. Is that something we need to worry about?
These ones, it's what I don't know what you could say the integers could be this, it could be that. It's a little less important. I think it's not too serious. It's just a suggestion in the book. All right, so here's a formula you might have seen before. So it says the number of diagonals on an n-sided polygon is given by d for diagonal equals n divided by 2 times the quantity n minus 3. A polygon has 35 diagonals. How many sides does it have? So remember that a diagonal is a figure that connects like vertex to vertex, so it kind of goes across that figure. So we can figure out how many sides this has. So what we can do to start is we know that there are 35 diagonals, so I could substitute that in for d. So I've got 35 equals n over 2 times n minus 3. Definitely that you could take different paths when kind of sorting this out. I'm going to start just by distribution. So when I distribute that n over 2, I've got 35 equals n squared over 2 minus 3n over 2. So when I multiply that out, n times n is n squared, 2 is still in the denominator. N times 3 is 3n, 2 is still in that denominator. Any ideas on how I could get not 2 in my denominator, how I could get rid of that? What do we got? Absolutely. We're going to multiply it by 2. But keep in mind you have to multiply the whole thing by 2. So every single piece. So that means 35 times 2 is 70 equals n squared minus 3n. Now this is looking like a quadratic that we can solve. So keep in mind, I know we've seen that strategy before when we've had like x in the denominator. I know we saw that in the first section, section 1A1, but that same kind of strategy here. I'm going to bring my 70 to the right because I like to keep my n squared positive. So I have n squared minus 3n minus 70. And now it's up to you if you want to complete the square or FOIL it, factor it, or use quadratic formula. It's your call. I think this one might be nice to factor. We need factors of negative 70 that give us negative 3. Very nice. Negative 10 and 7. I'm just going to switch it around so it's got our variables on the left like we're used to. Oh, there you go, plus 7. Thank you. That got me on track there. So the negative 10 plus the positive 7 is how we get that negative 3. So I end up with n equals 10, or n equals negative 7. And I think this is the first one where thinking about the appropriateness of our answers really comes into play. So I could have a polygon with 10 sides, or a polygon with negative 7 sides. Can I have negative sides on a polygon? That doesn't really make sense. So that negative answer doesn't fit. and see, we could write a sentence here. The polygon has 10 sides. Who remembers what a 10-sided polygon is called? Yeah, good job. Zach again. Alright, I think we're going to make a quick stop at the stop box, and then we've got another problem we're going to take a look at. Any issues so far with this problem solving stuff?
It's just a lot of work.
It is, but to me it's kind of, I don't know, it makes you think. It's not always just like, just do it. Alright, so my step box question is more of a reflection, like which step is most difficult for you. So just to take a moment to kind of reflect on your strengths and your experiences, and if there is something that's most difficult for you. And maybe you feel really good about it, but just try to think about maybe it's something that you need to remind yourself or be careful of or anything like that. Hopefully that's true. That you're doing self-test. Anyone want to share what step that they're kind of not sure about? Okay. Alright. So, yeah, this is a lengthy one. It says a rectangular box has a square base with sides x centimeters long. The height is 2 centimeters longer than the base side lengths. The surface area is 1,470 square centimeters. Show that the surface area is given by the expression 6x squared plus 8x. This example is kind of important because I think this is the first time in class we've had a show that problem. And you'll definitely see these more throughout the year. The thing about a show that problem is a show that problem will not have an answer in the back of the textbook because it gives you the answer right now. The answer that you should come up with is 6x squared plus 8x. So they're not going to have, if you turn to the back, it's going to be blank because the answer is right here. The part of the problem is that you need to show all of your steps. You need to show how you get from, point A to point B where that answer is. So we've got this basically like a prism. Is there a formula in your formula packet for surface area of a prism? I gotta check mine. Where's my formula packet? Let's see, we've got volume, volume, volume. I don't think we got one. So what do you guys think for surface area? Does anyone remember it? I'm going to give you guys that formula that we used back in geometry class. So the formula for surface area that you used in geometry class was 2 times the area of the base plus the perimeter times the height. So jot that down just in case you come across it in your assignment as well. So we got to figure out the base, the perimeter, and the height. Well, the height is 2 centimeters longer than the base. Well, the base side length is x, so the height's going to be x plus 2. Does that part make sense? Now, if my base is a square and it's x by x, how do I find the area of that? That area of a square, is that here a rectangle at least? Parallel here? I'm hoping you guys are just falling asleep. So that's x squared. What about the perimeter around this square? So they're all x's. So x plus x plus x plus x. That's going to be 4x. So the translating might be a little bit different on this one, but it's still possible. So what we can do is plug all of those pieces in. So I have 2 times the area of the base, which is x squared, plus the perimeter, which is 4x, times the height, which is x plus 2. So if I go about simplifying this, I've got 2x squared. Got to do some distribution, so I'll have 4x squared plus 8x. And then I can combine those squared terms, so I have 6x squared plus 8x. Which, sure enough, that's what I wanted to get. So that problem, or what you should do, is actually making sure that we can see your steps, because they give you the answer right away. So first time we've seen that, it's not going to be the last time you see that type of problem. So let's keep that in mind. Yes?
What do we do with the 1,470?
That's going to be on the next part of this problem, actually. Good question. All right. So this one does have a part 2, and that's going to involve the surface area of number. Why is this okay? All right, so find the dimension. Well, this is my not my formula, but my expression for surface area was 6x squared plus 8x. Well, what was that surface area? That it said that it was 1,470 centimeters. So that's where it's coming in. So now I have to find the dimension. So I have to figure out like the base and like both base edges, like the length and the width and the height. So I'm going to subtract that so that we've got 6x squared plus 8x minus 1,470 equals 0. Now, you haven't done quadratic formula yet today. Do you want to do that?
Yes.
Yeah. All right. So then I've got, you don't have to do it. Then don't do quadratic formula if you hate it. Don't do it. I'm pretty sure it's factorable if you want to factor it. Yeah, it's factorable. So if you want to factor it, feel free. I just kind of calculated my discriminant right away, so that's 35,344. And that's actually a perfect square, which is another reason why I know that it's factorable. So the square root of that is going to be 188. So now we can kind of split it up into both different parts. So negative 8 plus 188 divided by 12, and negative 8 minus 188 divided by 12. So for the first one, I get 15. But do I have to calculate this other one? If we think about it, whatever it's going to be, if I've got a negative minus a number, or a chain that's plus negative, this is going to give me a negative answer. Can I have a negative side length on my prism here? Nope. So I don't even have to bother with that one. So x equals 15, but remember that we do want the dimensions. So if x is 15, that means those side lengths, the length and the width, are going to be 15. But how big is the height then? Very good. Because it was x plus 2, 2 inches longer than that side length. I probably should have centimeters in here. So I know there's a lot on this, but it's really kind of like where all this other stuff is coming together. Now we have all these strategies, we have all these skills that we can use in order to help us solve problems. So, yep, it's a lot of reading, it can be a lot of writing, but kind of like showing off what we know in a way. Alright, so there is your assignment for 1F. Since we didn't have time to check homework on Friday,